welcome you to my lecture today. Today, we are actually going to continue from chapter 11. Of course, chapter 11 is the last chapter in the semester, which we call the additional topics in regression part 2. But you know what? What we want to walk you through today is what we call ordinal logistic regression. But I'm going to have a recap on, what we've done before. You remember, as I told you the other time, we find ourselves in a world where we basically want to use model to capture reality. And you know what? The type of statistical model we're basically going to use actually depends on the nature of data, particularly the response variable and the predictor. I remember when I started earlier in the semester, I actually we fitted a linear regression in a situation where the response variable is continuous. And of course, the predictor variable could be categorical, could be continuous, could be combination of continuous and categorical. And from there, we actually move into analysis of variance. Of course, in analysis of variance, it is required that the response variable should also be continuous, only that the predictor has to be categorical. Because in the analysis of variance, you basically want to compare, an outcome variable, the predictor across levels of, the response across levels of the predictor. And we can also have situation where in addition to the categorical predictor, we could also have quantitative predictor. And in that kind of situation, the analysis of variance becomes analysis of covariance. Now, from there, we move into a situation where the response variable is categorical. When the response variable is categorical, which means the response variable has levels, of course, we use logistic regression model. And I also walk you through a situation where both the response variable and the predictor can also be categorical. I walk you through how to use something that we call a chi-square test of association. We use a chi-square test of association when we are trying to analyze categorical variables. The response variable is categorical and the predictor is categorical as well. But you know what? On Friday, I also walk you through how you can actually fit logistic regression model to categorical variables as well. But let me just tell you in general, we have 3 types of logistic regression. Basically, I'm going to call them variants of logistic regression. Variants, just like the same way that you have the variant of COVID. Okay, you have the conventional COVID, you have other variant of COVID like Omicron, like Delta, and so on like that. We also have the variant of logistic regression, which I'm going to tell you. Number one of them is what we call the binary. The binary logistic is the one we have been doing where, the response variable has 2 categories. That's binary. Response variable has 2 categories, and these levels are not ordered. Okay, like a response variable like race. Okay, race, if I'm talking about, particularly if I'm talking about white and probably black, okay, now if I code this as 1, I code this as 0, that doesn't mean this is greater than this. It's just labeling. Okay, so in this situation now, this is not ordered. These categories are not ordered. Okay, now this is what we call a binary logistic regression model. Now another one is ordinal logistic. The ordinal logistic is what we want to do today, what I want to walk you today. I'm still going to talk about that. And we also have what we call multinomial logistic regression. You know, in ordinal logistic regression, the levels of the response are ordered. I'm going to tell you, I'm going to give you an example. That's what we want to do today. And what we're going to do on Wednesday is multinomial logistic regression. What is the meaning of multinomial? Look at it. But this is binary. This is like binomial. This is like having two levels. But for multinomial, that's when you have more than two levels. At times, the response variable could be more than two levels. With that, we're going to call that multinomial. When it is more than two levels and it is not ordered, we use a multinomial. Okay, so these are types of logistic regression. I've walked you through. Number one, the binary logistic, where the levels of the response, the response variable is categorical. It has two levels, but it is not ordered. But the one I want to walk you through today is what we call ordinal logistic regression. Okay. Now, I think I've in the outline, I said we're going to have a review on binary logistic regression. Then we're going to talk about the ordinal logistic regression. Of course, the binary logistic regression is just when you have two levels of the response. I think we've done a lot of example in this class where we got two levels of response. You apply to graduate school, it's either you are given admission or not. That's two levels of response. You apply for student loan, it's either you are granted or not. That's two response. I remember I walked you through an example that has to do, where we're trying to fit a model to predict a probability of a customer defaulting in a bank. It's either customer default or not. That's two levels. That's binary logistic. Okay. Now, on the ordinal logistic now, I'm going to walk you through what we mean by ordinal logistic regression. Let me tell you, in the ordinal logistic regression, you could have two levels, you could have three levels, but what really makes sense is having more than two levels. And I'm going to tell you, in the ordinal logistic, we consider more than two levels, and those levels are ordered. Okay, those levels, what do I mean by levels ordered? I'm going to give you an example now. Let's go to sports. Oh my God, I miss sports. Okay, let's talk about sport now. Somebody is considering, a researcher is considering factors, that actually influence winning Olympic medals in swimming. Of course, there are some factors that could determine that. But what are the levels of the response? I'm going to write, you're going to see the levels of the response. The levels of the response, we mean type of medals. Gold, silver, bronze. Now, when you take a look at this is the levels of the response, right? The levels of the response. And you know what? These are ordered. You know why? Gold is bigger than silver when you want to talk about the watts, right? Gold is more than silver. Silver is more than bronze. But let me tell you this. If the distance between gold and silver, the distance between this and this is greater than the distance between silver and bronze. Situation where you look at the distance between two successful levels of a response and one is greater than the other one, that is classified under ordered logistic regression model. So this is one example. Okay, I'm going to give you another example now. Another example is maybe a marketing firm conduct a research to determine factors that determine the size of soda. size of soda is Y, okay, that you're gonna order from a from a food restaurant, the size of soda could be small, medium, large, extra large. And let me tell you this, the distance between small and medium, okay, the distance, small, let me see, medium and small, the distance between them maybe 10 ounces. The distance between medium and large, 8 ounces, okay, and the distance between large and extra large, 12 ounces. Look at that. The distance between them, between small and medium, is different from the distance between medium and large, and the difference from the difference between extra large and large. Look at that. These are ordered. Of course, the predictor variable X here, predictor could be, the type of meal that you order, type of meal could be, maybe you order burger or chicken, okay? One of these predator here is categorical. The second predator, maybe whether you actually, whether you also include fries. Oh, I like fries. Okay, fries or without fries. Okay, and another predator could be age of the customer. Okay, age of the customer. Okay, now these are the predator. If I want to fit a logistic regression for this, I'm basically going to fit ordinal logistic regression. It's not going to be the conventional logistic regression we've been fitting. You know why? Because the levels of the response variables are ordered, and the distance between small and medium is not the same as the distance between medium and large, and not the same as the distance between large and extra large. And because of that, we're basically going to use ordinal logistic regression. I'm going to give you another example. A study looked at factors that influence the decision of whether to apply to graduate school. College juniors are asked if they are unlikely, look at that, unlikely, somewhat likely, or very likely. Those are ordered to apply to graduate school. Those are the levels of the response. Because you know why? The distance between unlikely and somewhat likely will be smaller than the distance between somewhat likely and very likely. The distance between somewhat likely or very likely will be larger than the distance between unlikely and somewhat likely. Those are ordered. Now, subject to what are the predictors? The predictor will be the parental education and status, because at times when you want to go to somebody, if a child want to go to a graduate school, that depends on, number one, the parent education is also could be a factor. Okay, then whether the undergraduate institution is public or private is another predictor. And what about the current GPA? Those are the predictor. Now, just like what I said, the reason why we're basically going to use ordinal logistic regression here is because the distance between the 3 points are not equal. What are the 3 points I'm talking about? The levels of the response. Okay, the distance between, and that's why I said, for example, the distance between unlikely and someone likely may be shorter than the distance between someone likely and the very likely. Okay, so that is what I wanted to say. Now, I've given you an example of ordinal logistic regression. Let me also give you another example. For instance, if you conduct a survey and maybe you are actually seeking perception of your customers about their level of satisfaction, probably about your service or product that you render. I know if you want to, you're going to have on a 5-point scale, you could have very satisfied, satisfied, dissatisfied, strongly dissatisfied, and so on like that. Those are ordered. Okay, those are ordered. Okay, now I want to uh, walk you through how to do this in now. I know this week my TA is also going to walk you through this, but I'm going to take you to an example now. How does the how coding for logistic regression model for the conventional logistic regression model different from the ordinal logistic regression model? I wanted to pay attention to this code now. Now take a look at this. I want to use a data set. This is a data set on, a college junior, applying to graduate school. I told you the other time, the response, the data set is actually here. I got that from the University of California, Los Angeles. Okay, the data set is actually here. And this is the first 6 in the data frame where apply, the levels of apply, we got 3 levels of apply. It's either they are very likely or somewhat likely or unlikely. You get what I mean? And of course, the PARED is a parent educational status. And the public is categorical. The public, it's either they attend a public, private, a public school or a private school. Okay, and GPA, the current GPA, we got 3 predator. Take a look at it. Okay, I want to do some explanatory data analysis on this, just for me to be able to understand my data set. Of course, as you can see, on GPA, you know what I'm trying to do here. I want to see what is the minimum GPA of the student, what is the maximum, and what is the median, what does it mean, and so on like that. So this is necessary. It's a descriptive statistics. Okay. Now, I wanted to take a look at this now. Please, I wanted to pay more attention now to the coding. I wanted to see this guy here. You remember in the logistic regression, in the conventional logistic regression, you're going to see GLM. But in the ordered logistic, you're going to see POLR. Look at the POLR. Do you see the POLR? We use the POLR for ordinal logistic. But for the conventional logistic regression that we have done before, it's just going to be GLM. And when you have GLM, don't forget, when you have GLM, you're also going to have family equal to binomial, right? Here, you don't see family equal to binomial. There's only like family equal to binomial here, because we are no longer talking about that. The levels, the level is more than 2. Okay, now take a look at this guy now. Apply is a response on parent status, on the nature of the undergraduate school, whether it's a public or private, and on the current GPA. Of course, I'm using the DAT. Where's my data from? Okay, you can just copy that. You can just copy this guy here. Look at that, DAT. When you copy the whole of that into R, automatically, you're going to have access to the data set. Okay, you can try that. You're going to see what I'm talking about. Okay, now you can see, you see POLR. The moment you do that, you're going to have a result. This is the result. But I want to show you something. On the logistic regression, you normally see Z value, right? Z. But right now, we are no longer talking about Z. Look at that T value. Pay attention to that. You got a T value, right? Take a look at that. You see that now, right? We got a T value. Okay, we got a T value. Now, when you take a look at what I have now, you're basically going to see I have 2 different kind of results. I got the one that has to do with the coefficient. Look at that coefficient. Okay, and I got the one that has to do with the intercepts. Look at that. Okay, this is the way ordinal logistic regression output now look like. Okay, and this is at the output now. So how are we going to interpret this, or how are we going to put this in a modeling form? Okay, now before I'm going to show you how we're going to put that in the modeling form, I first wanted to see here. Okay, the PRED, the public, the GPA, those are the estimate, the values are the estimates, right? You look at that. Okay, they are the estimate. You have the standard error, you have the t value, and the one down here is the one that has to do with the intercept. Okay, you're actually going to see two things here. Take a look at that. Unlikely versus somewhat likely, and somewhat likely versus very likely. Those are the two different comparisons that is going to take place. Okay, so take a look at that. Now, we also want to get the confidence interval. The confidence interval of what? If you look at the estimate here under the value, the PRED, the public, and the GPA, these are point estimates, right? A point estimate. You can also get the interval estimates for them. Okay, if you want to get an interval estimate for them, it's just going to be confit M. Where is the M? Don't forget M here. Look at that. M up, M equal to that. I want to get a confidence interval, right? The same way we get a confidence interval. The same way we get a confidence interval, just going to be confit. Take a look at that. When you do confit, then you're going to have the confidence interval for the parent state or the public and the GPA. Take a look at that. Now, when we have that now, how do we now interpret? Okay, how do we now interpret? Now, if we want to interpret, I want to tell you this. Whenever you are conducting logistic regression, the estimate that you have, they are log odd estimates. Whether the ordinal logistic or whatever logistic, they are always log odd estimates. Now, I may want to interpret the value of the PARAD 1.0477. I may want to interpret the estimate for the public and also for the GPA. Okay, now how am I going to do that? I wanted to pay attention now. I said for PARAD, okay, we want to focus on the parent status now. How does the parent educational status determine your consideration for graduate school? Okay, based on the result that we have, we want to make an interpretation on that. We will say that for 1 unit increase in PARAD, okay, going from 0 to 1, okay, we expect 1.05 increase in the expected value of the apply on the log odd scale. Now, where do we get 1.05? This is where we get 1.05 to 2 decimal. Look at that. The 1.04477 to 2 decimal is 1.05. That's a positive, right? So which means, okay, for every unit increase in the parent educational status, we expect an increase. Okay, increase of 1.05 on a log odd scale. Okay, on that was on the log odd scale. Look at that. Don't forget that's a log odd estimate, right? Now, what about for GPA? So for GPA, we will say that for 1 unit increase in GPA, we will expect a 0.62 increase. Where's it coming from? 0.62 increase. It's basically coming from here. Look at that. It's 0.62, to 2 decimal. That would be 0.62 on a log scale. Okay. But when you take a look at this guy, right? Whether the school it is a public or private, of course, that will lead to a decrease on average on the log scale. So look at that. What are we interpreting now? We are interpreting the estimate of the ordinal logistic regression. But let me tell you now, the same way that we interpret the estimate of logistic regression is the same way we are interpreting this. It's the same way, because those estimates actually represent the log odd estimates. Okay. Now, if you take a look at what we have here, this is a confidence interval of the log odd estimate. Confidence interval of the log odd. If I want to remove the log, okay? If I want to remove the log, what am I going to do? I'm going to do exponentiation. Oh my God, take a look at this. I want to find the odd ratio. Then I'm going to do ESP of, where OR equal to COEF of M, then comma CI. I'm doing the exponentiation, I want to remove the log. I don't want to talk about log odd. I want to talk about odd ratio. Because when I talk about, if I want to talk about odd ratio now, I actually want to compare a level of the response relative to the other one. And look at what I have now for PARED, for public, and for GPA. Okay, I wanted to see that here, the first values that you see here, those are the estimates. How do you think we can get this one? If you go back to the estimate, the log odd estimate, here, the log odd estimate in the value 1.0477 minus 0.588 is 0.6159. When you do the exponential reciprocal of that, the exponentiation of that, we basically lead to this guy here. And you know what? The exponentiation of the interval that you got before, you got an interval right here, right? You got an interval right here, right? When you do the exponential raised to power this, exponential raised to power this, exponential raised to power each of that, you're basically going to have what you have here. Okay, if you want to determine the odd ratio from the log odd ratio, you're basically going to find the exponentiation. That is what leads to this. That is a code. We can use odd, interpreting odd. We actually derive a lot of joy in interpreting odd ratio. Some of us may be having difficulty. How do we interpret something on the log odd scale? Log odd. But interpreting odd ratio make a whole lot of sense. Okay, now this is an odd ratio now, and the interval for the odd ratio, we have the point estimate of odd ratio. We also have the interval estimation of the odd ratio. Oh my God, how do we interpret this? I want you to pay attention now to how we interpret each of these. Okay, we want to start with the parental status. How do we interpret the odd ratio that we obtain in the parental status right now? In the parental status, 2.8511 and is the point estimate of the odd ratio, right? Why 1.6958 to 4.817 is a confidence interval for that predictor, that odd ratio. Now, let's interpret now. For students whose parents did attend college, I wanted to take note of that. For students whose parents did attend college, the odds of being more likely, okay, which is very or someone likely versus unlikely. Let me tell you this. We got three levels, right? You're basically going to compare two positive levels with the lowest one. The lowest level here is unlikely. So you are comparing very likely and or somewhat likely with unlikely. Okay, to apply is 2.85 times than that of student whose parents did not go to college. Where do I get 2.85? The 2.85 is there. The odd ratio, 2.85. So which means students whose parents apply college, attended college, okay, the odd of that student going to college, very likely, or someone likely to apply to college is 2.85 times than the students whose parents did not attend college. That's what it means, 2.85 times. If it is 1, if the odd ratio is 1, the meaning, 50-50. That means it doesn't matter whether the parent attended college or not. It doesn't matter. Okay, that doesn't really affect. But this is 2.85 times, which is more than 1. When odd ratio is more than 1, then it means it favors what you have in the numerator. Okay, so take a look at that. That is the interpretation of that. And you know what? Another, if you want to go the other way around, you can say for students whose parents did not attend college, the odds of being less likely to apply, less Like if you want to go the other way around, if you want to start from the student whose parent did not apply, did not attend college. So you're going to say be less likely to apply, which is going to be this time around, unlikely versus someone or very likely is 2.85 times than that of the student who parent did go to college. Holding constant, other variable. I wanted to say something here. At the end of the day, I mentioned in the two, holding other variables at constant because it is not only parent educational status that we consider as a predator. There are other predators as well. Other predator like the nature of the undergrad, whether the public or private, and the GPA. Okay, that was why we said after holding other variable constants means after adjusting for them or after controlling for them. Okay, that is how we interpret the odd ratio for the parent or the parent status. Now, what about school type? You know, the school type, public or private. Take a look at this here. The public or private, you can see 0.9429 odd ratio, and the interval is from 0.5209 to 1.681. Okay, so how do you interpret that? Okay, this is the interpretation now. For student in public school, don't forget, arrow actually return, part of the output you have a public. It means it coded public as 1 and it coded private as 0. That is why you see public appearing in your outputs. Okay, now the interpretation now is this. For students in public school, the odds of being more likely more likely means very or somewhat likely versus unlikely to apply is 5.71%. How do I get the percentage? To get the percentage, 1 minus is 0.943. Where do I have 0.943? You can basically look at what we have here. Give me 1 second. Yeah, you see, for the odd ratio here is 0.94 to 3 decimal, that is 0.943, right? Okay, you're going to subtract that from 1. When you subtract that from 1, okay, you multiply by 100. So when you multiply by 100, then that will give you 5.71%. So which means for students in public school, the odds of being more likely, okay, to apply is 5.71% lower, okay, lower than private school student, holding other constant variable. Holding other constant or other variable. And another way you can do this, you can just do 1 divided by 0.943. Look at that. 1 divided by 0.943. Okay. So 1 divided by 0, 1 over that is the odd ratio. So you're going to see that this is more than this, right? That 1 is more than 0.943. I just wanted to take a look at that. Now you're going to do the same thing for the GPA. For the GPA, when you go back to the odd ratio for the GPA, it is the odd ratio is 1.85, right? 1.8514 for the GPA. Okay, 1.8514, because what could influence you to say you want to apply to graduate school, that depends on your GPA. You know that, right? Okay, now right here, that 1.85, how are we going to interpret that? We say for every 1 unit increase in student GPA, the odds of being more likely, and you know what I mean, that more likely means very likely or someone likely versus unlikely, okay, it's multiplied 1.85 times. Where do I get 1.85 times? The 1.85 times is basically here. That's the ratio, right? The 1.85 times, okay, 1.85 times, okay, take a look at that, holding other variable at constant. Okay, so which means it increases. Okay, when you have a unit increase in your GPA, okay, that will increase your interest, right, in applying. Okay, but how many times? 1.85 times. Look at that. And another way we can actually interpret this, for every 1 unit decrease, if you look at the first one, I said for every 1 unit increase. If I do every 1 unit increase, I'm going to talk about more. If I do a unit decrease, I'm going to talk about less. If I do a unit increase, when I talk about more, I'm going to go from very likely, somewhat likely, versus unlikely. If I want to start from the less, if I want to start from the decrease, okay, if I want to start from the decrease, then I'm going to use the word less. And not only that, I'm going to start from unlikely versus very likely or somewhat likely. Okay, look at number 2. For every 1 unit decrease in student GPA, the odds of being less likely to apply, okay, unlikely to apply, unlikely versus somewhat or very likely is multiply 1.85 times, after adjusting for other predators. Is there anyone who need clarification on what we've done today? This is ordinal logistic regression model. You can see the difference between the ordinal logistic regression and, I think I have a chat from somebody who said, for public versus private education, how do we know the odds of public school student applying to grad is 5.71% lower and not 5.71% higher? That's a very good question. That's a very good question. Now I'm gonna go back into that now. I wanted to take a look at what I have here. Okay, I wanted to say, if you take a look at number two in the interpretation, okay, we're focusing on private school. We're starting from private school, right? And I want us to go back. Why is it that we say for students in private school, the odds of being less likely to apply is that? We're going to say it's because of the, take a look at the estimate. It's negative. Give me 1 second. Can the person see it's negative here? Negative, you know what that negative means? The negative, because the public is what R is considered here, then the one for public is less because of the negative. Where is the one for private? If you look at the private, okay, the private is private is being referenced because public is coded 1, right? Private is coded 0, and this guy here is an interpretation for public decrease. It's a decrease for public, and that is the reason why I'm going to go now. You're going to see there's something now. Now take a look at this. When I want to start number 2, I said for students in private school, the odds of being less likely to apply, okay, is 5.7% lower than public school student. So take a look at that. So what we put into consideration is basically the negative aspect, because you know why? You are comparing, anytime you see a categorical predator here, you are comparing public with private. Categorical, you are comparing one that show with the one that is not show. Okay? The one that show with the one that did not show. And that was the reason why when you take a look at the first one, I said for students in public school, the odds of being more likely, if I want to talk about for students in public school, what I'm going to do, if I want to get a percentage, I'm going to do 1 minus that is 0.943 multiplied by 100. And that was how, if you calculate that, you're basically going to see 5.71% that we talk about. And for students in private school, the odds of being more likely, because the students in private school will be more. Why is it going to be more? Because they say, look at that, I said, for students in private school, the odds of being more likely to apply is 1.06 times. How do I get 1.06 times? It's 1 divided by 0.943. Because 1 divided by 0.943, why do I put 0.943 at the denominator? I put a 0.943 at the denominator because that's for public. The private is on top. Why did I do that? Because of the fact that the public estimate is negative. Look at the public estimate here. It's negative. Public. It's negative. That was why. Okay. I don't know if I've answered the question to the. Oh, okay. Thank you too. Thank you too. Okay. Before I go today, I want to say I've already published exam 1 solution, exam 2 solution, and what you're going to see from me today is probably the final, a final practice question. I've already uploaded. I uploaded last night. Exam 1 solution, exam 2 solution.